In this monograph, we will talk about omega-3 fatty acids in the diet. And let's start by looking at what omega-3 fatty acids are. The main nutrients in food are carbohydrates, proteins, and lipids, and these nutrients are considered macronutrients because they are our main source of energy. Among the most important lipids are triglycerides, formed by a glycerol and 3 fatty acids, and the phospholipids, formed by a glycerol linked to a phosphate group and 2 fatty acids. Fatty acids are divided into saturated and unsaturated fatty acids. And the unsaturated ones in turn into monounsaturated and polyunsaturated. Saturated fatty acids such as stearic acid consist of a chain of carbons, in the case of stearic acid of 18 carbons, without any double bonds. Unsaturated fatty acids are also carbon chains, but in this case with double bonds. Unsaturated fatty acids can be monounsaturated fatty acids, such as oleic acid, which has a single double bond. The carbon containing the double bond determines the name of the fatty acid. Oleic acid has the double bond at carbon 9 and is therefore an omega-9. Fatty acids with more than one double bond such as linoleic and linolenic acids are polyunsaturated. The position of the first double bond determines the name of the fatty acid. Linoleic acid has the double bond at carbon 6 and is therefore an omega-6, while linolenic acid has it at carbon 3 and is therefore an omega-3. In saturated fatty acids, the absence of double bonds in the carbon chain means that they have a straight structure, so they can be compacted and are therefore solid at room temperature. Foods rich in this type of fatty acids are, for example, coconut, bacon, or butter. Monounsaturated fatty acids, having a double bond in the carbon chain, have a certain curvature so they cannot be compacted as saturated fatty acids do and leave some space between them, which gives them fluidity, and for this reason they are liquid at room temperature. Foods rich in monounsaturated fatty acids are, for example, avocado and olive oil. Polyunsaturated fatty acids have several double bonds in the carbon chain, so they still have greater curvature and consequently greater fluidity. Foods rich in this type of fatty acids are sunflower oil, nuts, or oily fish. Trans fatty acids are polyunsaturated fatty acids, in which double bonds are artificially modified to avoid curvature, resulting in straight structures that can be compacted and are solid at room temperature. Foods rich in trans fatty acids are margarines. Monounsaturated fatty acids include omega-9 fatty acids, while omega-3 and omega-6 are among the polyunsaturated fatty acids. In this monograph, we will talk about omega-3 fatty acids. The most important omega-3 fatty acids include linolenic acid or ALA, which is an essential fatty acid, that is, we are not able to synthesize it and we must therefore incorporate it in our diet. Eicosapentaenoic acid or EPA, and docosahexaenoic acid or DHA. These two omega-3 fatty acids can be synthesized from ALA by adding carbons and double bonds and are therefore not essential. And which mechanisms are attributed to omega-3 fatty acids? Omega-3 fatty acids are necessary for the formation of eicosanoids such as prostacyclins, thromboxanes, and leukotrienes, and also in the formation of resolvins, the nervous system, and neuroprotectants. Prostacyclins and thromboxanes have important effects on blood vessels. Prostacyclins are vasodilators, while thromboxanes are vasoconstrictors. Thromboxanes play an important role in wound healing and bleeding control because, in addition to being vasoconstrictors, they also induce platelet aggregation and blood coagulation. When an injury occurs, thromboxanes induce platelet aggregation and subsequently the formation of a clot by activating the production of fibrin. The third type of eicosanoids in the formation of which omega-3 fatty acids are involved are leukotrienes. Leukotrienes are key in immune cell recruitment and edema formation. Omega-3 fatty acids also participate in the formation of resolvins, which, as their name indicates, participate in the resolution of inflammatory processes, mainly by preventing neutrophil penetration. Omega-3 fatty acids are also very important in the formation of the nervous system. Omega-3 fatty acids are an important component of the nervous system. For example, in the retina, the omega-3 fatty acid DHA accounts for 70% of all the fatty acids that make up the retina. Finally, omega-3 fatty acids also participate in the formation of neuroprotectants, relevant in the protection of neurons. And now let's see which properties are attributed to omega-3 fatty acids. By their participation in the formation of prostacyclins and thromboxanes, it is considered that they may have an effect on cardiovascular diseases. By participating in the formation of leukotrienes and resolvins in inflammatory diseases, and via participating in the formation of the central nervous system and the production of neuroprotectants in neurological diseases. It is considered that omega-3 fatty acids could be beneficial in preventing cardiovascular diseases because they increase arterial dilatation, lower blood pressure, decrease the formation of atherosclerotic plaques, among others. However, an evaluation carried out by Nutrimedia has not found sufficient evidence to prove it. Nutrimedia is an initiative of the Pompeu Fabra University of Barcelona, the Observatory of Scientific Communication, and Cochrane Ibero-America, and consists of a website of scientific information on food and nutrition aimed at the general public that provides rigorous analyses of the degree of confidence that deserves some messages that are disseminated in the media and social networks. Nutrimedia concludes after analyzing the scientific evidence that there is not enough evidence to support a protective role of omega-3 fatty acids on cardiovascular diseases. Omega-3 fatty acids are also considered to have a beneficial effect on inflammatory diseases such as allergy, hepatitis, and autoimmune diseases including rheumatoid arthritis, Crohn's disease, psoriasis, or lupus. A beneficial effect of omega-3 fatty acids on the development of the nervous system and in the prevention of neurological diseases has also been suggested. During the first years of life, there is an important growth phase of the brain. Omega-3 fatty acids appear to be very important during this period for optimal formation of the central nervous system. In fact, it has been shown that supplementation of DHA to the diet of infants in proportions similar to those of breast milk improves visual acuity and several parameters associated with cognitive development. Later in adulthood, it has been suggested that omega-3 fatty acids may also be beneficial by reducing the risk of suffering depression or memory problems. However, the analysis conducted by Nutrimedia questions whether the evidence available to date demonstrates a positive effect of omega-3 fatty acids on depression. Multiple sclerosis is both an inflammatory and a neurological disease, since both inflammation and neurodegeneration are pathomechanisms. Consequently, it is considered that omega-3 fatty acids could also have a beneficial effect on this disease. For the fatty acid ALA, although there are still no clinical trials, there are observational studies carried out through questionnaires that suggest a beneficial effect of this fatty acid in multiple sclerosis. For the fatty acids EPA and DHA, there are several clinical trials suggesting that their consumption may benefit people affected by multiple sclerosis. Some of these studies have been conducted with oil from oily fish rich in these fatty acids and other studies with supplements. And which foods are rich in omega-3 fatty acids? Foods rich in ALA are, for example, flax seeds, flaxseed oil, and walnuts, while the main source of EPA and DHA is oily fish, including canned oily fish and shellfish. Regarding doses, the recommended daily amount of ALA varies depending on age and gender. Babies less than 1 year old require 0.5 grams daily, and this amount increases with age during childhood. From adolescence onwards, recommendations vary according to gender, being higher in men than in women. In general, adult men need 1.6 grams of ALA daily and women 1.1 grams, except during pregnancy and lactation, periods during which these requirements are higher. These doses can easily be obtained through food. 1 tablespoon of flaxseed oil provides 7.3 grams of ALA. A tablespoon of flaxseed 1.6 grams, and half a dozen walnuts 2.6 grams. A tablespoon of other vegetable oils such as canola, soybean or mustard oil also provides about 1 gram of ALA. The recommended daily doses of EPA and DHA are around 250 and 350 milligrams per day. Daily supplemental intakes of EPA and DHA of up to 5 grams do not increase the risk of adverse effects such as bleeding, alterations in the regulation of glucose levels, or immune function. Here you can see the amount of these fatty acids provided by 100 grams of some oily fish or seafood. 100 grams of mackerel provides about 4.5 grams of these fatty acids, of salmon 2.1 gram, of sardines 1.4 grams, of herring 2.1 grams, of oysters about 0.3 grams, of anchovies about 0.4 grams, and 100 grams of caviar about 1 gram. At the moment, as far as we know, the optimal doses of omega-3 fatty acids for people affected by multiple sclerosis have not yet been established, so our recommendation is to follow the doses recommended for the general population. Finally, let's talk about the balance between omega-3 and omega-6 fatty acids. As mentioned above, omega-6 fatty acids, like omega-3 fatty acids, are polyunsaturated fatty acids. And as we have seen in the omega-3 fatty acids, in which a linolenic acid or ALA is an essential fatty acid, and from it, thanks to enzymes capable of adding carbons and double bonds, we are able to synthesize EPA and DHA. In the case of omega-6 fatty acids, linoleic acid or LA is the essential fatty acid, and from it we can synthesize gamma-linolenic, dihomo-gamma-linolenic, and arachidonic fatty acids. Arachidonic acid, as well as DHA, participates in the synthesis of eicosanoids. But while DHA participates in the synthesis of series 3 eicosanoids, arachidonic acid participates in the synthesis of series 2 eicosanoids, the effect of which is opposite to that of series 3. Arachidonic acid facilitates the formation of prostacyclins that reduce vasodilation, thromboxanes that increase platelet aggregation, and leukotrienes that increase inflammation. It is therefore very important that there is a balance between omega-3 and omega-6 fatty acids. In fact, the recommendation is around 1 gram of omega-3 fatty acids for every 4 grams of omega-6 fatty acids. However, because there are many more foods that contain omega-6 fatty acids than omega-3 fatty acids, the result is that we normally ingest far more omega-6 fatty acids than omega-3, which can be detrimental. It is therefore important to increase the amount of foods rich in omega-3, and if it is not possible, to consume omega-3 fatty acids as a supplement.